Hello and welcome to this tutorial on interface segregation principle or ISP. ISP is one of the 5 solid principles, and in this tutorial we will learn what is ISP, why it is required, and how it helps make our code more flexible, more modular, and easy to reuse. So my name is Arjun Thakur and you are watching Tech Pro School. Let's get started. So let's go to the code. Over here we have a package solid principles. We will create another package over here, ISP. Let's create a sub package in here before. So this will hold the code before applying ISP. So we will write some code in this package and see what are the problems before we apply ISP to the code. So let's create a class before ISP. Now ideally you should create different classes and interfaces in their own separate Java source files or files in any other language. But right now, for sake of demonstration, we are keeping everything in the same file so that you can take a look at the entire code. So let's go ahead and create a plant interface. Now a plant can have several methods. Let's say, so a plant will have a grow method, it will have a flowering method, and then a plant can also have fruiting method. So a plant will have these 3 methods: grow, flowering, and fruiting. Let's go ahead implement this plant interface, right? So for example, let's say we create a class mango and it implements plant. Now of course we will need to implement the methods. So for sure, a mango plant can grow, it can have flowering, and then of course it will have fruits. So all of these 3 methods can be present in a mango plant. So let's create another class, rose. It will implement our plant interface. So the rose plant can have grow method because it will show some growth. It will have flowering method because it will give some flowers as well. Now this one is trickier one, fruiting. So all of us know that rose plant doesn't give any fruits, but because rose is implementing from the plant interface, so we have to give it some dummy implementation, right? Or we at least need to print that, okay, this operation is not supported. Now the problem is this code is stale code. It is not really required. And right now it is just one method, fruiting, right? But tomorrow you might have really big interfaces. By big, I mean the interfaces with a lot of methods into them, right? And if a class is implementing such an interface, then it will be bloated with a lot of unwanted code, which is something we do not want. So this code clearly violates interface segregation principle. ISP says that your interfaces should be modular. It should have small number of methods so that they can be reused effectively, as well as they do not force the implementing class to implement unnecessary methods, right? So what we are going to do next is we will change the code a bit. We will segregate the interfaces, meaning we will break down this plant interface into multiple smaller interfaces, and then we will re-implement the rose and mango classes. So essentially what we are going to do next is, instead of having a big fat interface plant, we are going to have smaller interfaces. So what we are going to do is we are going to rewrite this code. For that, what we will do is we will create another package in here. Now over here we have the plant interface. So we will just copy this code, go to the after. In here we will create a new class after ISP. Remember, previously we have written plant code like this, but now we are going to segregate this interface, meaning we are going to create multiple interfaces out of it. So we will create interface plant, and we know there are different type of plants. Some are flowering, some are fruiting, all of them are growing, but then there could be plants with specific features, right? So what we will do is we will keep the plant interface very simple, right? In here we will not have any methods. Don't worry about the error because we have duplicate interface names here. We will just get rid of the first one in a minute. So for now, what we are going to do is we are going to create smaller interfaces. So let's say we have interface growing plants, and it will have just one grow method. So let's move this grow method from here to here. Similarly, we will create another interface fruiting plant, and it will just have one method fruiting. And let's go ahead and create our final interface flowering plant, and it will just have one method flowering. Now we have this plant interface. Let's get rid of the first one because we have already segregated it, right? So get the same classes for mango and rose. So for class mango, we know that mango has all these three qualities of growth, fruiting, and flowering. So what we'll do is we will make it implement growing plant, fruiting plant, and flowering plant. And of course, this will implement all the methods. Now, previously the problem was with the implementation of rows class. So let's rewrite that now, class rows. Now we know that a rose plant can grow. So we will implement growing plant, and it also flowers. So we will implement flowering plant. And we also know that the rose cannot have fruits. So we can safely ignore that interface. And we of course need to implement these methods in here. Now your code becomes more reusable because you can reuse the flowering plant interface, you can reuse growing plant interface, you can also reuse fruiting plant, you can also reuse fruiting plant interface as and when you want it. Now as we have segregated that interface into smaller interfaces, it is easier for us to reuse it for future use cases as well. So now our code becomes easy to extend. So let's imagine tomorrow you have another plant, let's say banana or pineapple plant. So let's say we create a pineapple class. Now all of us know, so pineapple is a special type of plant. It does grow, it does have flowers, but then it does not have any flowers, or even if it has flowers, they are not really noticeable. So for pineapple, we will only implement growing plant and fruiting plant. We can just safely ignore flowering plant because it doesn't flower. Once again, we need to implement these two methods, fruiting and grow. Therefore, it is always advisable to use interface segregation principle in your code. And if you take a look at the libraries of some of the programming languages like Java or Python, you will see that the interfaces are fairly aggregated, right? They do not have a lot of methods. So the same thing is what we need to apply in our code. So we need to follow the same practice while we write our own code. So that's all in this tutorial about interface segregation principle. So I hope this tutorial on interface segregation principle has been helpful. Please do like, share and subscribe, and thank you for watching. Once again, my name is Arjun Thakur and you have been watching Tech Pro School. Thank you very much for your time.